at your home studio, you're definitely gonna do that, you know, which is why Dan has the reclaim bucket. And, you know, he takes that and dumps it out, dries it out, puts it through the pug mill, but if you don't have a pug mill, it's all manual. So, you know, thinking of that.
I was about to say, if anyone wants to ask about how to reclaim clay in a studio like this, I have my bucket over there and I've been doing it since I've been taking classes
You
here.
can definitely reclaim it, it's just you gotta wedge it.
Yeah, you do.
Sorry, go ahead, we were discussing.
That's good.
I was going off on,
Yeah.
I was going off on how you don't really have traps in the sinks, and somehow it's worked
Yeah.
in your second floor,
Never
but
had a
that's not
problem.
the case in our homes.
Well,
May not be,
I don't know.
yes, it's magic, dance place is magic.
So, I'm just gonna read off a couple of things. Advantages of having your own studio. That's something to consider. Advantages of having a co-op studio. The economics of having a studio in your home and the economics of a co-op. We kind of touched on that stuff a little bit. And the cost of taking classes. You know what that is. So you can think about those things and see how that works. Now, I've got a long list here. Firing. Okay, we talked a bit about different types of firing. I can talk to you about starting the electric kiln and ventilation and all that stuff. So here is the control panel on the electric kiln.
Turn the TV so
And you can't all get back there, but
you have to turn the TV so everybody can see.
I made a video, and I'll put it online. If I wanted to turn part of the hill, I would just press fast bisque, and it would say FBC fast bisque, enter. Then it would show the cone that it's supposed to fire to, and it's whatever cone I fired to last time is gonna come up, which is 06. I press enter, and then I just press start, and I'm firing.
Can I ask what options you have to fire using an smaller electric kiln?
Right, so there's a slow bisque and a fast bisque, and you can program in whatever temperature you want, but typically a bisque is cone 06.
Is that for all types of clay?
Yeah.
How old is your kiln?
Huh?
How old is that kiln?
I have an ancient one and a relatively
Do you notice a difference between the old one and the new one? Are there any?
not for biscuing. Blaze firing is much more sensitive. Now, why would you choose slow or fast? Well, if the pots are wet, which they shouldn't be, there's no reason to be putting wet pots in a kiln or even damp pots. But if they are damp, you need to fire more slowly, because once the internal temperature gets above the boiling point, you're gonna get steam and they're gonna explode. Another factor is the thickness of the pot. So if they're a reasonable thickness, like the thickness of my fingers, you know, I can fire on the fast bisque cycle, but when we're talking about things like my thumb thickness, you should probably be using the slow cycle. These cycles take about, the fast bisque in my kiln, the way I load it, is 12 or 13 hours. And then it takes even longer for it to cool down. And I don't do glaze firings in my electric kilns, but it's relatively simple, and there's some pre-programmed things in here.
Does the time that a kiln, bisque takes to occur, so like you said, 12 to 13 hours, is it based on the size of the kiln, so you get a smaller kiln?
It's not really based on the size, it has more to do with the mass of the load.
I have no idea,
So, you know, if you have 300 pounds of pots in the kiln, it's gonna take longer than if there's 50 pounds or 20 pounds. Just because there's more stuff to heat up. But in theory, this thing is gonna try to make the kiln fire at a specific pre-programmed rate. So, if you've got more mass, it's just gonna put in more heat to try to get it all to fire.
Oh, right, cause the pots will absorb, okay.
Right.
You said you don't use the electric kiln for glazes, why is that?
Cause he's
Well,
got a big
because
roof
all my
downstairs.
glazes, are high fire glazes. And when I got started, I was very attracted to the Asian palette, you know, the copper reds and the celadons. And you can't get the celadon and copper red in a electric kiln. You can get something that looks kind of like that, but it's not really the thing.
So are you saying that the electric kiln doesn't fire to a high enough kiln temperature?
No, it's the atmosphere.
Atmosphere.
Yeah, so the gas kiln has a reducing atmosphere.
Right, okay.
And like copper in oxidation is green and in reduction can be red. So I can get the red downstairs. I don't get green copper for the most part. But in the electric kiln, it's gonna be green.
Basic question for those of us who have not even completed a full pot yet. So there's two different firings. You throw or whatever, you bisque fire, which can be done in a kiln like that to whatever temperature it needs. You glaze and then you fire again, and the result of that firing depends on the glaze that you're using and the heat of that second firing, right? So you can use one kiln for both of those firings, but you choose to use.
Definitely.
Okay.
I could bisque downstairs, which I can do. I could glaze fire up here.
Cool.
And I
You just
could,
have to adjust.
I could fire to cone 10 up here, which is almost the same temperature as I'm firing to downstairs.
But no reduction.
But no reduction,
Okay.
different colors.
So what is different between the bisque kiln and the glaze kiln? So on that, keypad, you're saying there's bisque kiln like buttons and then there's glaze kiln buttons. If you're, what's the difference between the two different types of?
The
like-
cone,
Temperature.
the temperature.
Yeah, but you can adjust that separately.
You can, but the downstairs one, you have it set for reduction.
It's
Explain
It's not
this.
exactly set. The downstairs one, I turn the knobs and push the damper in.
Right, no, I'm just saying like, why isn't this just on? It's
yeah.
going to fire and I want it to be on for 12 hours and I want it cone 6. Or why is there a separate bisque and glaze on this? Does that make sense? Do you know what I'm
What's
asking?
the
Difference between a bisque
So,
program and a glaze.
so here's a chart.
Ooh,
So here's
high tech.
temperature and time. And this is the intersection of 212 degrees, and that's when the water in the pot's gonna boil. So what does a typical firing ramp look like? Well, the beginning of the ramp is gonna be fairly slow. This should take about 2 hours. And then, after that, it can go more steeply. And then, on a bisque kiln, it's just gonna turn off and cool. But on a glaze kiln, or glaze firing, you're gonna taper off like that, and
Okay.
hold it for a while, and let the heat soak, and then it's gonna turn off and drop. And when it cools,
It's more
it
gradual.
doesn't, you know, it cools very
Okay.
slowly.
Thank
So
you.
Explain,
if this is 12 hours to here, which is obviously not looking too good, because if this was 2 hours, that's not 12 hours. But,
explain to everybody why the glaze downstairs, what reduction is. Cause I'm not sure people understand the difference between like why an electric kiln can't accomplish what your gas kiln does.
yeah.
Am I, does
Doesn't
that make
Yeah,
sense
like
to everybody?
reduction of
That would be
oxygen,
helpful.
reduction
Yeah,
of
well, he'll
what?
explain it.
So, let me
Cause
give
it is
you
something I
a
think you
better,
don't know here, that they're two just separate, really separate types of kilns.
okay, this is more like regular firing cycle, where the beginning is pretty slow the first couple of hours, and then you go up faster, and then you kind of plane off. And that's the way, glaze firing would go. A bisque firing would look the same, except you would just keep on going up and then turn it off. And you
Bisque, or
wouldn't
you
go,
mean glaze?
actually, this is not right, because that's showing a higher temperature. For a bisque, you would just go up to here and turn it off.
So the programming dictates how hot for how long. It dictates the time that the temperature is being held, less so than the temperature itself.
Yeah, it's like
A soak at the end is like half an hour or so. You're slowing it down, because if you kind of imagine glazes as honey, they're gonna melt, slowly, they're gonna sinter and go through a number of stages, but toward the end of the firing, they're gonna be like honey, and it's gonna be boiling and gases are gonna be coming off. And you wanna give all that an opportunity to settle down. Otherwise, you get what's called pinholes, and it looks like little craters. If you can imagine a bubble that froze in the middle of bursting, that's why you wanna soak at the end, to let all those volatiles get out, to allow the glaze to settle down, and to allow some flow. If you've got fluid glazes, you want them to start to move a little bit. Okay, so that's what this end part is about. And there's other things in here like quartz inversion, and that happens down here and again up here. So you want to go fairly slowly during quartz inversion. So if we add that in, you're going slowly, and then you quartz inversion and end soak like so. Okay.
That's the crystallization ones.
Quartz inversion has to do with a sudden change in volume.
There's too much to know.
It's basically, if you have a bunch of triangular objects in a bucket, and then within 10 minutes they turn into a round objects, and how would they reposition themselves, and how would that affect the volume, the stuff in the bucket? So that's what quartz inversion is.
So downstairs, how does the gas kiln function differently than an electric kiln?
for reduction firing.
Like how, what is so different about the
So-
gas kiln that you could not do in an
So
electric?
the term reduction means that you're reducing the amount of oxygen in that's entering the kiln so that the flame is oxygen starved. Now, an oxygen starved flame is a different color and has a different odor. And when you're reducing, the fire needs oxygen. So it starts to strip oxygen out of the clay and the glazes. And that affects the color. And an electric kiln is just a giant toaster. There's no atmosphere to speak of. And it just applies heat.
So you could get a reducing atmosphere in an electric by pumping in CO2.
You could.
I'm
and-
thinking that's dangerous.
Yeah, we are talking about home studios.
So Linda's house, Linda's gonna have the kiln at her house.
So people,
But basically, that's what you do in a gas kiln. What
Right.
the atmosphere in a gas kiln is mainly CO2.
right, yeah. Yes, in the gas kiln, when
Linda,
you're
I like
reducing,
Carl.
you're
Well,
generating,
That's why I'm here.
you're generating O2. When you're reducing in a gas kiln, you're producing carbon monoxide. And carbon monoxide is unstable, and it says, give me one more oxygen atom.
Yeah.
Grabs them, yeah.
Does reduction have to be done at high temperatures, so cone 9 through 10, or can you do reduction at those lower temps?
That's a good question. It was traditionally done at high temperatures, but I think it would work at cone 6. Now, I start reducing at below the bisque temperature. I start reducing at O10. And maintain a light reducing atmosphere throughout the fire.
So you actually control when the reduction process starts
I
in the
control
heating
when it
timeline.
starts and how reducing it is.
Do
You
you
do that by
have,
closing the dampers to, less oxygen in?
You can either, you have to do something to change the ratio of gas and air.
Yeah,
And there's lots of ways you can do that. But the damper is one thing, and, turning up the gas is another. You can reduce down at the burner level by controlling the,
air fuel
gas and
mixture.
air ratio right there.
Uh,
I use the damper primarily.
okay.
do you have an oxygen probe?
I have an
that goes
oxygen probe.
into- And what like percent saturation then do you hit when you're like, say you're at your peak reducing atmosphere?
The oxygen probe is less useful to me than my nose and my eyes.
Oh, I know, they're the most useless.
So, and I think the numbers that I could quote you would have more to do with maybe the age of my probe and things like that. So I don't think you could transfer that. But, point five, point 0.65.
Yeah, but you're not going like fully anoxic, you're just, there is some,
That's where I am in the reducing cycle.
So it's not likely that people are gonna have a reduction atmosphere in their
Exactly.
home.
Yeah, I was about
Is
to
that
say,
correct?
if you live in the city of Pittsburgh, you cannot have a gas fire, unless it's already grandfathered in. Like, that's why, Pittsburgh Arts and Media, they have their gas fire. They can never get rid of it, cause as soon as they get rid of it, they cannot get another one.
And then, of the studios you know in Pittsburgh, around Pittsburgh, or even in the United States, what percentage are studios firing at reduction versus electric? What do you think off the top of your
I
head?
really couldn't say.
Okay.
I would say though that with the improvement in oxidation firing, it's a very good option. You know,
What does that mean? You said with the improvement in
Well-
oxidation fire, what do you mean?
What I mean is, when I started, all the cone six glazes sucked.
So basically, they're better glazes, they
Yeah.
respond better to, and,
Right, there's been
And oxidating.
tremendous improvement in glaze formulation.
Available to people.
So,
It's
here's a book on mid-range glazes, and these are oxidation glazes, and it's a good book. And here's one on high fire glazes, and they're written by the same guy. So, they're great books. There's a ton of information on the web, of course, and I can recommend all kinds of stuff for you.
So how much, and I know everybody will know this because we calculated it a couple weeks ago, how much does it cost to fire a bisque?
Okay, so the easiest way to do it is, you can just look at how many amps it draws and so on. But the thing is, when you get electricity, they're charging you for delivering it and for this and for that. So it's not just how much you use. It could be a small percentage of your overall electric bill if you have a big electric bill, but it's fairly high if you have a tiny electric bill. And for the gas kiln, if I wanna know how much gas it uses during the summer, when I'm not using gas for other things, I can simply read my meter outside before the firing, read it after the firing, and calculate how much gas I use. I can go to my electric bill or my gas bill and say, okay, I'm paying this much per cubic foot of gas, and I just used that much gas, so, just do the math.
I think when we figured it out, I was astounded because it was inexpensive what I thought.
What did you come up
We
with?
came up with like $12
Yeah, that's about right.
for the bisque kiln, for a full fire bisque kiln. Now that also included, because Dan has special rates if you run at night, I mean, electricity is a nightmare to figure out. But I was surprised, because he is a fairly large kiln that is holding all of our stuff for Bisque, cause that was about 12, but we did not figure out the gas gallon. But I thought $12 in terms of a hobbyist is not an unattainable, amount to use, kind of
So,
thing.
does anyone have any idea what home insurance, what the home insurance companies think about having a kiln in your home?
That's not something you talk to your insurance company
Just
about.
don't tell them.
Oh, great.
You just cover it with a screen and it's fine. I don't know. I don't know anything. I would, and this is because I have a particularly old kiln that I've gotten from somebody, and it actually doesn't even have a monitor on it. Like, I would have to physically watch it, watch the cones melt, do all that. I'm like, oh God, I'm terribly nervous about it. But I'm not even planning on having it in my home. Like, I'm gonna put it outside, because there's just no reason, it's scary to me.
You have a
Is it
shed.
electric kiln? Do you have
It is electric, yeah.
Is it, 220?
It's
or-
220, yeah. So,
The electric kilns are, I guess, all 220. Is that
I don't
right?
know.
They're all 220.
They
Yeah,
are?
Unless they're like a tiny toy.
when I look at people online and what they have set up, it's all, they have concrete floors and concrete walls and that kind of thing. My whole house is finished, so
Yeah.
it's,
What is 220 refer
So
to?
the electric, is that what you're talking about?
yeah, 220
And is
volt
that
washing.
a regular one, or is that the special
No.
kind for
It's
your
a
washing
special
one?
It's like a
Or
special one, like for your dryer,
Yeah.
or for,
So
electric
because
cars.
you need like the appliance, there's an actual cone.
You know what I mean? So it used to be, before you had electric things, you have cones, right?
Yeah, I'll show you.
It used to be, and I can remember firing the glaze kiln downstairs many years ago, like pulling out the thing and looking at the cones to see how far the cones had fallen. Because the cones are designated for each firing temperature.
Okay,
So like cone
gotcha.
6, the cone would fall, and you'd be like, okay, I've reached cone 6, now I do this,
Okay,
that kind of.
so,
But you don't do that anymore.
hey,
Well,
Liz,
in-
run down and get some cones off.
The new kilns, electric kilns, but if you get a hand-me-down like me, then you gotta figure all that out. Now,
So these are cones, and Liz,
that's what I figured.
Uh,
I might as well try
hey,
it.
Liz,
I'm going,
Liz,
yeah.
to the left of the kiln.
Yeah.
Right by the glaze room door.
Yeah.
There's a vertical cabinet, get a cone pack.
Oh, sure.
There's a ton of fire.
Okay.
So these are parametric cones, they come stuck together, I break them apart, I roll out a snake of clay, I position these in that, and they are supposed to be leaning at that angle. And there's a picture on the box of what it's supposed to look like, and they sell little cone holders that you can put these things in. They also sell cones that have little feet on them, so that they can be freestanding. And those are the big cones, and these are the little cones. And when they get hot, they bend. So this is an 06 cone, it's gonna be red. And it's gonna be red because there's a lot of iron in this cone. And iron is a good flux and makes things melt.
So you don't even need to use those in your electric kilns, right?
I do not, but I used to, and I'm gonna show you.
Yeah, but you use them in your reduction kiln?
I do, yeah. So this is the kilns for the cones for the electric kiln. So this is the before and after. So they melt sequentially, they're formulated for specific temperatures. So when we're talking about firing, what we wanna know about is heat work. So like when you cook a turkey, you stick it in a hot oven. And the oven's 350, but we're sticking the turkey in a cold oven. And we're trying to get that turkey inside temperature up to where we want it to be. And that's the heat work. What has the heat done to the turkey? We don't want to just burn the skin. We want to cook all the way through. So this represents heat work, and I can show you more about these cones. Now,
Ta-da! Which for me will be helpful.
Huh?
But most people will use electric kilns where this may not. But
right,
if you get a used kiln from somebody else, you wanna test it first. Like, you would wanna put cones throughout the kiln to see if it evenly fires and stuff, right?
right, and to see if the elements are even good. So this is the mechanism is the mechanical mechanism that is on the old electric kilns. And this is the Dawson kiln fitter. And when you go look at used kilns, this is what you're gonna see. You can see this contraption. And here is the wiggly thing here. Okay, so the way this works is, you put a cone in here, and I've got this one set up with the little rods in there. So you lift this up, and you put the cone in here, and then this drops down like so. Now, when it gets hot, the cone bends and makes a U shape, and as this rod dips on that end, it's like a little seesaw, and you can see the other end goes up and down. So I'm gonna wiggle a rod, and slight movement over here. And then, this is totally mechanical, and when it does that, this gadget here will fall. So I'm gonna pick up the rod, bang, it falls. And when it falls, it pokes something and makes this pop out. So this, you put that up, hold that, press the button, and now the kill is on. And this is a timer, so when this drops, you'll hear the button snap out. Okay, so this button popped out, and that turns off the kill, because when it's pushed in, it's closing the circuit. It's just like a light switch. When it pops out, it goes off, and this is your secondary safety mechanism. So the primary turner offer is the melting of the cone, and the backup is the timer. So if you know, for example, that it takes about 10 hours to fire the kill, if you set the timer for 11 hours, you can't overfire too much. And without that, you can just fire forever. So,
But the newer kilns are,
Yeah.
the newer kills,
like a brand new kiln obviously is gonna have all the bells and whistles, which then of course attracts all the issues of electronic bells and whistles that we all have, you know, so.
yeah, so we can, I would love to spend a lot of time on all this stuff, but let's just take a quick look
I'm
at
just doing a dip into
this.
everything.
This is delay. Okay, so this is if you want the kill to come on later. So when I fire 2 kills, I don't want them both firing at once. I set one of them to come on
Why don't you
15
want
hours
both
after
firing
the
at
first one.
once?
Huh?
Why not?
Well,
Oh.
because I have a demand meter and it
Oh.
bills me extra when I suck a lot of electricity at once.
So things to think about.
You guys don't have demand meters, but
Okay.
industrial buildings do.
Okay.
And,
But what if we got an industrial building? This is stuff we need.
okay. Preheat controls the beginning of the cycle and just increase the amount of time that it's staying below boiling. And when you're done, you can push this button here, that's the program review. After the kill is on, you push that, and it's gonna flash through everything right here. And it's gonna say fast bisque, cone 06, 18 whatever thousand degrees, and whether you have a delay or a preheat or a hold soak at the end. This is the soak up there. It'll tell you how, because you can add those things if you want to this easy firing thing. But it's not that hard, and you get a manual, and you get a manual. Mine, you can read all that stuff. Okay, so let's just talk about the room where you're gonna fire. So, here's a room. It would help if there was a window over here somewhere. And if that's where the window is, and you wanna put your kiln in front of the window. Okay? And you want about 12 inches clearance between the kiln and the back wall. And now, this kiln's gonna get hot and there's gonna be some stinky fumes. So you wanna enclose the kiln, so you're gonna build a little, 2 walls here on either side. out of 2x4s and drywall on the inside. You want 2 sheets of drywall. Okay, and in the
Does
front,
it have to be fire rated or anything?
that would be fire rated.
Okay.
2 sheets of drywall and you're good.
Okay.
And depending on what's overhead, you might wanna put some drywall up there. Then, to contain the heat, you wanna have a curtain here. And, it could be like a shower curtain, but the idea is that the heat that comes off the kiln is gonna rise and it's gonna naturally go out the window. But you are gonna wanna put an exhaust fan in the window to help suck air out. And you are going to wanna have below the kiln, and here's the kiln. There's a thing called an enviro vent, and it is down there, and it's got a pipe that comes out, and that's gonna come up and exit the building with a regular dryer vent. Okay?
It doesn't
So-
need a fan? No fan for that vent?
Yeah, there's a built-in fan.
Oh,
What's it
okay.
called?
Well, they're brand names.
Oh, okay.
But I'm familiar with the term enviro vent, but I don't know if that company's still even in business. And the exhaust fan is generally located somewhere else, like maybe over here. Or maybe up here.
Now, if you fire outside, then
Well,
then do you need, you do.
this is a good idea because, it keeps the negative pressure in the kiln.
Okay,
So you have a couple holes drilled in the top and the bottom. And it's sucking air out. The holes in the bottom are bigger than the holes in the top. So there's a negative pressure in there. And your control panel on the side of the kiln is not subject to gases leaking into it.
okay,
Because if there were any gases, they would be going into the kiln instead of creeping out. Okay, so it's good for your control panel, and it keeps the air in there clean. So you should have that.
regardless of inside or outside.
Right.
What's the minimum
I would recommend
footprint for a basic kiln in a home environment?
But,
The minimum
Size.
footprint of
okay, so kilns are, so there's a 12-27, and what that means is 12 bricks around the perimeter, and 27 inches from the floor to the lid, 12-27. Typically, these kilns have 3 sections, and they're typically 27 inches high if you're gonna get a normal big kiln, but you can get little tiny kilns too. So a 10-27 would be 10 inches around, 10 bricks around, and 27 inches high. And if you all come back here for just a minute, I will show you what they look like.